Okay, class. So, hey, this is our presentation for today. Unfortunately, I'm at the end of the presentation, so we're going to start out with the top. So, elements, compounds, and mixtures is our new unit. And so, what you can see here are various compounds, elements, and mixtures that we're going to look at. We've learned about atoms, and now we're talking about the things that are made up by them. So, the essential question is, what's the difference between elements, compounds, and mixtures? The biggest thing we want to teach you today is the fact that these are different things, that they're not the same. And we want you to be able to recognize what those differences are and identify them in nature. So, Dmitry Mendeleev, old guy number one. Actually, this guy is known as the father of the periodic table. He's a Russian chemist and inventor, formulated the periodic law, arranged the periodic table by atomic weight and similar properties, and predicted the properties of 8 elements yet to be discovered. Dmitry Mendeleev began the process of creating the periodic table that we know today. So he's actually kind of a big deal. Um, and it's important to give people credit where credit's due. So there's actually an element named after him as well that's more recent. Matter, we know about matter. We've learned about these, right? Everything around you has mass, it takes up space. And we can be solid, liquid, or gas. And we've already determined what those molecules look like. We know that that can be atoms or molecules, or it can be things that exist in a mixture. So the things that we're talking about are still states of matter, right? These mixtures, compounds, and elements can all be in different states of matter. Classifying matter. So this is the big thing that we're trying to teach you, that we can actually classify matter into different things. All matter exists. We have pure substances, which are what they are, and then we have mixtures, which are a combination of those substances. In a pure substance, we can have pure elements, which are all the same atom. That can be even a molecule, but it's still the same atom. Or like aluminum, it's the same atom. It's an aluminum sheet of metal, but it's all aluminum. Or we can have compounds, which are 2 or more elements together. With mixtures, we can have what's called a homogeneous mixture, which means it all looks the same. That's what homo means, is the same. So, or you could say genius. I would say homogeneous. All of those are solutions, like Kool-Aid. It all looks like a red liquid, right? Or you can have a heterogeneous mixture, which is where you can see all the different parts. So like pizza, Italian dressing, where you see things floating around, right? Anything where you see solid differences between the objects in that mixture. So, I mean, like M&Ms in your popcorn, which is one of my favorites. That would be a heterogeneous. Hetero means different, so you can see the differences. In a homogeneous mixture, you can't. So this is what we're going over today. Uh, so a pure substance has a definite constant composition. It's an element or a compound, meaning it stays the same unless there's a reaction, right? And the composition of a pure substance doesn't vary. All right, you can have salt or you can have sugar. So basically, pure substances are those things that are chemical compounds or just atoms formed in a molecule. So these aren't, we're not mixing these together, right? So we can have a molecule, which is, this says 2 or more atoms bonded together. The important thing about a molecule is actually that they are non-metals. No molecules have a metal in them. So it's basically a compound of non-metals. It can also be a compound of the same element. So it could be like O2, like 2 oxygen atoms, but they're bonded together. That would be an element, but it would also be able to be called a molecule. It's the smallest particle in a chemical compound that can take place in a chemical reaction. Has the same chemical properties of the element or the compound. And then some molecules consist of 2 atoms of the same element, like oxygen. Other molecules consist of 2 or more atoms, like H2O. Okay. Elements. Elements are pure substances. They can't be broken down to any other substance. So it's all one thing, like aluminum or gold or I don't know, O2 even actually is all oxygen. So we still call that a molecule, but it's technically an element as well. So anytime you're dealing with one element from the periodic table in nature, that would be an element, obviously. It's a pure substance, and you can't change it. It's represented by the symbol on the periodic table. So all elements have a symbol. We know that from our last unit. And the example here is gold. And the symbol for gold is AU, which is different. Compounds. So compounds are a pure substance formed when two or more elements have chemically combined through a chemical reaction to form a new substance. So table salt, which is NaCl, which is right here, is a compound. Compounds always have a metal in them. So technically, H2O is a molecule while NaCl is a compound. So compounds are those things with a metal and a non-metal usually, but there's two different substances. So, I mean, sugar is a compound. It has carbon, hydrogen, and oxygen. It's represented by a formula. And so this is an example of that. You have the first element and the second element, and they're listed in a formula, which we'll go over more as our unit goes on. This is actually table salt. Now we have mixtures, which are quite different, right? These are not pure substances. A mixture is a combination of different elements and compounds, and it's not chemically combined, meaning they're not bonded to each other. They're just put together, okay? And they can be separated out. Even a homogeneous mixture, which everything looks the same, can be separated out. Just think about Coca-Cola. That's what happens when you open the pop can. The carbonation that's in your soda separates out from the liquid and fizzes to the top and leaves. So eventually that Coke gets flat. That's really because the mixture is separating out. The gases are leaving, and you're only left with the dissolved sugar and the water. And you have types of mixtures. So we talked about heterogeneous means different. The parts can be seen. I can see the different parts. This is a great example of that. And that would be like M&Ms, right? I can see the different colors. I can tell the differences in the mixture. Homogeneous mixtures where you can't see the parts. So milk is a homogeneous mixture, and so is Coca-Cola, what I just referenced earlier. Okay. So our whole goal is, can you differentiate between elements, compounds, and mixtures? So next class, we're going to look at different objects in nature, and you're going to be able to identify that's an element, that's a compound, or that's a mixture based on what we learned today. Okay, y'all, hopefully this helps out. Now you can take your notes for the day using this video and the slideshow in the assignment. And afterwards, you can watch any of those links that I posted for today on our